students, today we are going to see something important topic, that is amine. In that, first and foremost, we are going to see how do we get primary amine from nitrohydrocarbon. So this is actually a very important and common question. Okay, now here this is actually also known as preparation method. How do we get primary amine from nitrohydrocarbon? Nitrohydrocarbon, it is nothing. Generally, nitroalkane. Okay, combined with the hydrogen. You know how do we get this primary amine? That is from reducing agents. So that means that reaction undergoes reduction process. So reduction process means in the presence of SN bar HCl. Then with concentrated hydrochloric acid, you are getting what it is, or NH2, alkyl amine plus H2O. Okay, so this is a reduction process. So in the reduction process, one among we have seen. Okay, now particular this general, particular we can go CH3, CH2, NO2. Nitroethane combined with the hydrogen in the presence of tin with the HCl, concentrated HCl, you are getting what it is, ethylamine, CH3, CH2, NH2 and water. Okay, now the same way you can take anything, any hydrocarbon with whether it is alkyl or aryl, NO2, nitrobenzene combined with the hydrogen, the same idea only, SN bar HCl. So you will get aminobenzene NH2. So this is a famous, what is this NH2 with benzene ring? What do we call? Aniline. What do we call? This is aniline. Okay. See, in that term, haloalkane, halorine part also, we have gone through this points and all. So that is what in that point only I just mentioned. We will learn in that amines part also. So in that amines, very clearly we will learn most of that haloalkanes questions will be interrelated with this topic. Okay, so organic chemistry always interrelated. So whichever we left, we will catch hold of in this. Okay, now generally reduction process only now. So what are the reducing agent we can use it? So generally lithium aluminum hydride and Fe bar HCl, concentrated HCl, of course this Sn bar HCl and H2 bar platinum and H2 bar nickel and H2 bar palladium. So these are all reducing agents generally we will use. In the most important we prefer, this is iron with con HCl only. Why do we go for this? You know, iron with HCl, iron combined with HCl, you will get FeCl2, and then it generates HCl with that small amount of HCl only, the reaction initiated. So the reaction initiated means generally you will get more amount of the product. So that is the reason they are using what it is, Fe with HCl. So Fe with HCl, what happened? Fe combined with HCl, you will get FeCl2. This FeCl2 produces HCl acid. That acid initiates the reaction faster. So that is the reason we are preferring Fe bar HCl. Hope you're clear with this point of how do we get primary amine from nitrohydrocarbon. Okay, alkyl amine also we can say here primary amine. Okay, the next one what we are going to see, it is alkyl halide. Okay, now already I just mentioned now alkyl halide. How do we get primary amine from alkyl halide? That is very interesting. Let us go for that question to analyze it. Hope you're clear with this. The next question, how do we get alkyl amine from alkyl halide? It is so simple, you know. Alkyl halide combined with ammonia, alcoholic ammonia, and 373 Kelvin if you heat, you are getting alkyl amine. Okay, let us go for it. CH3, CH2, Cl, alkyl halide, combined with ammonia, alcoholic ammonia. Okay, alcoholic ammonia with the 373 Kelvin in that sealed container, sealed tube. You are taking these two content. Okay, now what you are getting here? And small rearrangement, I just put it here, NH3 only, no? HNH2. I just mentioned NH3 only, but here HNH2 I just mentioned. So what happened here? HCl. So HCl, what is it? Remaining CH3, CH2, NH2. CH3, CH2, NH2. We got it alkyl amine, ethyl amine combined with HCl. Okay. Now the next one. This is alkyl halide. Aryl halide also we can go for it. You know, this is benzyl halide. We can go for it. Benzyl halide, CH2Cl. Okay. Now combine with ammonia, the same ammonia with alcoholic ammonia only with that sealed container, 373 Kelvin, same thing only. Okay, now here also small rearrangement I just mentioned, NH2. So NH3 only I just mentioned, small rearrangement here. So what happened? Here HCl, and then here what it is, CH2, NH2. So what it is? Benzyl amine. What do we call here? CH2, NH2. So this is benzyl amine and you are getting HCl. Okay, now this cleavage. Okay, now I just mentioned here both the thing. Here alkyl halide combined with alcoholic ammonia at 373 Kelvin. If you heat, what happened? You are getting alkyl amine. Okay, in this small important note to be minded. Okay, so in that, first and foremost, this reaction, it's a cleavage taking place carbon with the halide. So carbon with the halide, that is cleavage involves with that ammonia. So ammonia acts as a nucleophile to attack this halide, to remove that halide in that place NH2 group which is going to attach. So ammonia acts as a nucleophile. In that point, this is ammonolysis. What do we call here? Ammonolysis. Ammono, ammonolysis. Okay. So what is it, ammonolysis? It's nothing. How to prepare that alkyl amine from alkyl halide. That is only. So they may ask the question, what do you mean by ammonolysis? Explain with example. What happened here? So the CX bond, what is the CX bond here? Carbon connected with the halide, so that is CX bond. So CX bond cleavage, that is happens, what it is, bond cleavage which is involved, ammonia which is involved. Ammonia acts as a nucleophile. Why? Because ammonia has that lone pair of electrons. So the lone pair of electron acts as a nucleophile to attack that halide ion, to remove that halide ion, and NH2 which is going to attach. Hope you're clear with this ammonolysis, and one more point also we are going to note down. Hope you're clear with this point, ammonolysis versus what is this? Alkyl halide. How do we get alkyl amine from alkyl halide? Hope these two points also you have got it. In this we understood alkyl halide reacts with ammonia, you are getting primary amine. Suppose we are adding large excess of ammonia, we are adding to that methyl halide. What will happen? We are getting methyl amine. You will get it. Methyl amine will not be quite, because methyl amine reacts with the excess of methyl halide. You are getting a secondary amine, tertiary amine, and quaternary ammonium salt. You will get like cycle. You will get one by another product. Okay, let us see for that. Okay, now this is what it is. Methyl amine, we got it already. Methyl amine, we got it. CH3NH2. Okay, that is happened due to that large amount of ammonia we added, we got methylamine. Okay, now this will react with CH3I, that is methyl halide, methyl iodide. Now what happened here? CH3 NHCH3. Now what happened from this one hydrogen and this one iodide? These both will combine together. You will get hydrogen iodide. Now the next one, this will not be quite. Now the second thing, this is the first one. Second one, what will happen? This CH3 NHCH3. Now this is what it is. This is secondary amine. This is primary amine and this is secondary amine. So secondary amine CNH, which is attached with 2 methyl. Dimethyl amine, we can say. Okay, now again it will react with methyl iodide CH3I. So what will happen? This also. Now from this only the hydrogen will be taken over from here only. Okay, so what you will get it? CH3 N CH3, here CH3 and here hydrogen iodide. Okay, now next one, the same way, third point, CH3 NCH3 and here CH3 combined with again CH3I. So what will happen here? So you will get the salt formation, tetramethyl ammonium salt iodide. You will get it. So N here CH3, CH3, CH3 and CH3 and these combined together, this is a salt formation I minus tetramethyl ammonium. Ammonium, it is what it is, NH4. Ammonium salt, NH4 plus, right? The same way, this is ammonium salt of iodide. This is plus and this is minus. So that is what we mentioned. So this is like cyclic chain reaction, like one upon the other. See, because of excess of ammonia, we are adding to that primary amine, you are getting, this is a secondary amine, this is tertiary amine. This is tertiary amine. See, tertiary amine only one nitrogen. Here secondary amine NH and primary amine NH2. Hope you're clear with it. And this is the salt of what it is? Tetramethyl ammonium salt of halide ion. Okay. Hope you're clear with this. Hope you understood those names and all. Okay. Now the next one we are going to see today. Now, the quaternary ammonium salt reacts with the strong base. What is the product? Let us check it. R NH3 plus X minus. This is the quaternary ammonium salt combined with the strong base. What you will get it? You will get primary amine only. And you will get what it is? NaX and H2O. So this is the product you will get when this quaternary ammonium salt, that is quaternary ammonium halide salt combined with strong base, you are getting primary amine. Again you will get that first product only. Hope you're clear with it. The cycle comes and end it to that first starting only. Okay, like that you will get it, that first product only. Hope you're clear. Okay, now we are going to see another one more question. Now the next question, how do we get primary amine from nitriles, that is cyanohydrocarbon from cyanide group? So this reaction generally reduction process, okay, and in that reaction is also known as Mendes reaction. Okay, let us go for it. This is CH3CN, right? Methyl cyanide combined with the hydrogen reduction process I mentioned, So here what happened? Nickel acts as a catalyst and 413 Kelvin, 310 atmosphere. Okay, now what happened? You will get CH3, CH2 and NH2. You will get it. Okay, now here you just see here only one methyl group it is there and one, that means two carbon is available. But here number of carbon is increasing. For number of carbon increasing, for that purpose we are using this reaction. So this reaction undergoes what it is, reduction process, and this reaction is also known as Mendes reaction, and this is converted cyanohydrin, it's converted into primary amine. To increase the number of carbon we are using this reaction. Hope you're clear with this. Now the next question, how do we get amines from amide? It's very simple and easiest. This reaction also undergoes reduction process. Okay, generally amines, how do we, preparation method all gets from reduction process only. Please remember that trick. Okay, now here in this process lithium aluminum hydride we are using. Okay, now amide, R C double bond O NH2. So this is amide combined with the hydrogen. Okay. In the presence of lithium, aluminium hydride, you will get what it is, or CH2 NH2. Okay. Now here for example, CH3 C double bond O NH2 combined with the hydrogen, you will get what it is, in the presence of lithium aluminium hydride, you are getting CH3 CH2 and what it is, NH2. So this carbon 1 2 the same only here, so you are getting primary amine only. Please remember, you are getting primary amine only, and here it is 2 4. Okay, hope you are clear with this point to be noted. It's very very important. Okay, now the next question, Gabriel phthalamide reaction, it's a very famous reaction, and Hoffmann's degradation. These are the two questions we are going to see. Hope you're clear with this. Now, the next important question, Gabriel phthalamide synthesis. And in this process, we are going to prepare only primary amine, that too what it is, aliphatic primary amine. We cannot prepare aromatic primary amine. Okay, let us go for it. In that, mainly we are going to take the ingredient phthalamide combined with the potassium hydroxide. Okay, now phthalamide, what is a phthalamide? You know, phthalic acid. Okay, now this is COOH and this is COOH. This is phthalic acid. Okay, now phthalamide means these both the same. Here C double bond O, here also C double bond O. These both combined with NH. So this is phthalamide. Okay, so this is what it is, phthalamide. Phthalamide. Amide. Okay. Now, this reacts with potassium hydroxide. You will get potassium phthalate. Okay. So, here what you will get it? The same C double bond O. Here C double bond O. These both connected with what it is? N and K. Okay. Now, this is these hydrogen and this OH combined with what it is? H2O. Got it? Okay. Now this again reacts with methyl halide. Okay. Now this is phthalamide. This one. Okay. Now the next one, potassium phthalamide. Is it visible? Yes. C double bond O and this is C double bond O and these both connected with N K. So potassium phthalamide combined with methyl iodide. Okay, now what happened? You are getting methyl phthalate. Okay, so you will get this compound. What it is? C double bond O, C double bond O. These both connected with NCH3. And this K combined with the halide, potassium iodide, that is halide I just mentioned, iodide, methyl iodide. So potassium combined with hydrogen, you will get potassium iodide. Okay, now this one Again, it will go for the alkaline hydrolysis. Okay, let us go and rub this point. Alkaline hydrolysis. Alkaline hydrolysis now here in this point. Here, this is C double bond O, C double bond O. These both connected with what it is? NCH3 combined with KOH. Okay, now what happened here? Okay, so here strong alkaline hydrolysis, if you take place, means here what happened, this KOH, not two KOH is there. So O, K and H, here O, K and H. So what happened? COOK and then COOK you will get it. Now in this one hydrogen here, one hydrogen, these combined with nitrogen, you will get NH2. So CH3NH2 you will get it. We want primary amine only, and this process is meant for primary amine to prepare. That is what it is. Alkyl primary amine, that is aliphatic primary amine only it is possible to prepare. Come on, let us go for the product. Here, potassium phthalate. Here, COOK. Here also COOK. And here, CH3NH2. And this is primary amine. Okay, this reaction meant for to prepare primary amine only. That is what it is. Methyl amine, that is what it is. Aliphatic primary amine only you can prepare. Now, reason why it cannot go for aromatic primary amine. Now the reason is aryl halide, due to the partial double bond, that carbon connected with the halogen which will not react with potassium phthalamide. So that is the reason we cannot get aromatic amine, only we can get aliphatic primary amine only we can prepare from Gabriel phthalamide synthesis. Okay, you know what is the drawback from Gabriel phthalamide synthesis? Why can't we go for that aromatic primary amine? Because I have given that message. Hope you're clear with it. What is that Gabriel phthalamide's product to prepare primary amine? Hope you're clear. Okay, now we are going to see Hoffmann's degradation reaction. The next important question, it is Hoffmann's degradation process. Okay, Hoffmann's degradation process, what is the product we are receiving? Primary amine only. What do you mean by degradation? Removal of atom from the molecule in a specific chemical transformation. Okay, now what is another name of this reaction? Hoffmann's bromamide reaction. So what are the reactant we are using? Okay, for that we are using acetamide only. CH3, C double bond O, NH2. Acetamide combined with potassium hydroxide along with bromine, you are getting what it is here, CH3, NH2. Okay, now CH3NH2 means a carbon, number of carbon it has decreased. So the carbon group, CO group has converted into K2CO3. Potassium carbonate, CO group has converted into potassium carbonate along with KBr plus water. Okay, so potassium KBr. Okay, now here 4. Now, see, now this is what it is, primary amine. Hope you're clear. Now, hope you understood what is degradation. Removal of carbon only. So, removal of carbon, here 2 carbons are available, but here only 1 carbon it is available. So, the number of carbon which is decreasing for that purpose. I think you have got that idea. Number of carbon increasing method, which is cyanohydrin, that means is cyanide group. For that we are using that number of carbon it is increasing, whereas number of carbon decreasing, we are going for Hoffmann's degradation. Degradation removal. Hope you remember that. Methyl amine, the number of carbon which has decreased, and this CO group, C double bond O, this CO group converted into carbonate, potassium carbonate. Okay, hope you're clear with it. And I think you all got all those important questions in preparation method. Generally, you have got it. Hope you're clear with that. Thanks for watching.